Hey all! Welcome to the second episode of the Working with Textures or Images or even Frames using Codebox in jit.gl.pix. In the previous episode we looked at how to load images and how to fit them to the width or to the height of the window. So for example, if the window is this big, then fit to height will basically push the image at a point in which it will fit on the height of the window, but will cut out the sides of the image which don't fit in the window, and fit to width will fit the image to the width of the window, and in case the window is too small it will cut out the upper part and lower part of the image. Cool. In this video we are going to see how we can zoom inside the image. Cool, so let's go inside the jit.gen and let's check this out. This is the code as we left it last time, the Codebox code. So the first thing we need to do inside this code is to basically replace here the norm argument for this function with actually the new chords variable that we created, which is assigned to norm. So why do we do that? Let me unlock the patch. Why do we do that? Because we want these coordinates to modify them and then use them inside the function. So we want to use the modified coordinates, not the standard norm coordinates. So then inside the function themselves, we actually need to replace this norm.epsilon with chords.epsilon, because otherwise it's going to simply start from scratch and take the default normal coordinates, while we actually want to use our modified coordinates. So the same thing in the other function, fit to height with norm.x becomes chords.x. And this is basically it. We could refactor a bit this code and just use one single function for both these codes, but actually it's not so important. For the moment we are going to leave it like that. So cool, let's create another function now and call it zoom. So let's create it under fit to height. So let's call it zoom. Yeah, let's simply call it zoom, and let's give it the zoom amount. So zoom amount, and of course the coordinates, so chords. Let's go on a new line, create a couple of graph parentheses, and let's zoom in. So it's going to be very simple. So let's see what happens if we just zoom like this. So zoom coordinates per equal to the zoom amount, and then we return the chords. Okay, let's create a parameter here, param called zoom amount, and let's give it a value, default value of 1. So by default it doesn't zoom. Then before we call the fit to width and fit to height, let's call the zoom function. So new chords equal zoom new chords. We need to pass this variable as an argument to the function itself because we want to modify it. First actually let's pass the zoom amount and then the new coordinates, and that's it. And we got an error because oh, I think the problem is that we are writing to an output only variable. So let's create a different variable and call it zoomed chords equal to chords multiplied by zoom amount, and then let's return zoomed chord and see if this is good. Okay, so that was the error. We were returning, we were modifying a variable which is a read-only variable because it's an argument to the function. We cannot actually modify this variable apparently in Gen in Codebox. There's a lot of stuff that I discover myself as we go doing these videos, because actually in other programming languages you will be able to write on this variable, but in Gen it's apparently not like that. So perfectly fine, we just need to know it. So let's say that we would give it a value to the zoom amount of 0.5. Actually, let's create a message here, call it zoom amount $1, and then let's attach it to a float number, and let's start to zoom in. And this is actually wrong behavior. Let me see. I think we have something wrong here. Oh yeah, because we left the norm x as a variable here, which is wrong because otherwise it's going to use the default coordinates. We actually want to use chords.x, so our modified zoomed in coordinates. cool. So let's try again, and okay, so as you can see, it is zooming in, because the coordinates, we are multiplying them by the zoom amount, and they're getting smaller. So if they get smaller, we actually zoom in. If they get bigger, we actually zoom out, because we get, you have to imagine that this goes from 0 to 1 here, and then it goes from and then it goes again from above 1 to whatever number it arrives here. So the bigger it is the zoom amount, the smaller the image actually becomes. And the smaller is the zoom amount, the bigger the image becomes. But if we want to zoom in the actual center of the image, we need to translate the coordinates to the center, and then to translate them back to the original place. This is how you zoom or rotate, or you make any transformation. You first need to push the actual state of the coordinates, then you need to do your transformation, and then you need to pop it back to the previous state. Otherwise, it will always rotate or zoom in starting from the 0, 0 point. So we need to translate this 0, 0 point to the center. So to do that, we just need to do this. We need to subtract 0.5 from the coordinates. So let's make a little paint. So let's imagine these are our coordinates that goes from 0 to 1. If we subtract 0.5 to that, so let's say this is our x coordinates. If we subtract 0.5 to that, then basically 1. Oh, and a pattern of mine just discovered the error I made with the coordinates while I'm doing the video. That's pretty amazing. Cool. So I was saying, if we subtract 0.5 to that, this becomes, the minimum point becomes minus 0.5, and the maximum point becomes 0.5, and the 0 is actually here in the center, so we basically translated the 0 into the center of our coordinates. If you imagine this in 2 dimensions, then it becomes pretty clear, because we do the same with the epsilon, and then it's the same in 2 dimensions. We basically move the 0 point of the coordinates in the center of the image. Great. So, okay, so we subtract 0.5, then we zoom. So zoom chord per equal at zoom amount. Good, and then we need to get it back where it was, otherwise it will not work. So then we need to sum 0.5 to that. Cool. So let's try to zoom in now, and cool, as you can see, we are zooming in starting from the center of the image. Take a new image. Great. As you can see, when we zoom out, it's going to replicate the image, because by default the nearest will wrap around the image. So once it arrives, once the coordinates go above 1, they will start from 0 again, and then sample the image again. So we could do a simple trick as we did with the edges for the other functions. So let's do actually like this. Let's create the edge value, let's call it 1. Let's create a value of 1, and then let's say, let's actually copy these lines here. There's probably a better way to do that, but for the moment we just copy it. So if zoomed chords is less than 0, let's try that. Cool, and then let's return these and edge, and let's assign also the return value to edge. So let's check this out. Okay, it's not doing much. Because then edge is going to be overridden here. Okay, so what we need to do is to not override edge here, but to actually input it as not as an argument to the function. So to the fit to width and fit to height function. So in this way we are able to keep the edge the same that we got from the zoom function. So let's actually, of course we cannot write to input to an argument as we saw before. So let's call this like new edge equal to edge, and let's do the same in the fit to width. Okay, cool. And let's check this out. It seems to be to have completely overridden our image, and that's because I had a bug. There was here a dot. It actually should be a comma, otherwise the code will not work. But it was also not throwing us an error. That's why I didn't realize it from start. So another thing that was wrong is that actually here we need to return new edge and not edge. So before was edge, but actually should be new edge, of course, because we are returning the modified edge. Also, we actually had to modify edge here, so the new edge here, so not edge as it was, but actually new edge. And the same goes for the fit to height. So let's check if both work. Fit to width seems to work. Fit to height doesn't work, so let's go inside, check what's going on here, and it seems that it's using edge. Cool. And inside here is returning new edge. Oh, I think that's because this is only taking in account the x coordinate exactly. So I think if we do something like this, like back 0 0, let's see if this works on vector as well. It doesn't seem to no, it doesn't seem to work this way. So what we need to do is to actually specify both for the x and the y coordinates. So exactly, we have to do something like this. If zoomCord.x is less than 0 and zoomCord.x is greater than 1, and then edge equal to 0, and then we can actually say or zoomCords.y smaller than 0. Great, and then we do the same here. So we use the or, which will make the statement true if at least one of the two comparison is true. So if zoomed chord x is less than 0, it will put the edge to 0, but also it will do it if zoom chord epsilon is less than 0, or if both are less than 0. So at least one of the two must be true in order to make this statement true. So good. Let's actually make this as an else if. Okay, great. And now seems to work. So let's check this. That this works with fit to width and fit to height. Okay, great. This seems to work. And once we have got these, we can then zoom in. Great. As you can see, once we go in negative numbers, negative zoom amount, it will reverse the image, which could be something that we don't want. So inside the code, we can actually clip the zoom amount to 0 on the smaller side. So let's say create here zoom amount clipped. It's equal to clip. No, actually, let's say maximum of zoom amount, and the maximum between zoom amount and 0. So in case zoom amount is less than 0, this will give us 0. So then we have to use zoom amount clipped as our zoom amount value. And there seems to be an error because so maybe prefers this to be max. No. So if we try to clip it, then we got some troubles apparently. So max between 0 and zoom amount. Let's try that. Okay. Okay, so this seems to work. This clips the value at 0 inside the code box. Cool, which could be something pretty useful. Try another image. Great. Fit to height, fit to width. And then we can zoom in. Great. I would like also to show you quickly how we can actually move in the image using the coordinates. So it's very easy. Let's actually create another function so we keep this whole code pretty modular. So let's call this function zoom move, and we need to give it the coordinates as the first argument. Let's actually keep the coordinates as the first argument also in the zoom function. So we give it a bit of coherency to this code. Actually, we should do it also with the other functions, but okay, for the moment, let's just leave it like that. And then let's give it like move amount, which is going to be a vector 2 because we move in the x and the y direction. So basically what we're going to do is to say chords plus equal move amount, easy like that. Theoretically we don't even need a function to do that, but let's just use a function to keep the code very nice, modular. So let's create another param here and call it move amount, and let's give it, it's a vector 2, so it's going to be 2 values of 0 and 0. Okay, so before we zoom, no, actually after we zoom, then we can move the coordinates. So let's say new chords equal to move of a value. So we need to pass in the new chords as they were before and the move amount. And we got a problem because as you can see, I get a lot of errors because I'm not so used to work with Codebox. I don't work so much with, so there is a lot to learn for me as well in order, so talking about understanding the syntax. So what is the problem here? So you can see the error reporting is not super clear always. See if this works. If we just cancel this function, somehow the zooming factor went back to zoom from the top here. So there must be something going on here. If we delete this function, this must be, okay, sure. So I was actually not fault of this function. The problem is, okay, apart this line, the problem is that I changed the order here of the zoom amount and the new chords, but I didn't change it in when I'm calling the function, so super stupid error. Sorry about that. Okay, so now it's cool. This is still not cool because maybe thinks this is... okay, of course the problem is again that we are not returning anything and we cannot actually write on... we cannot actually write on an argument, so let's do like this, and then let's return. So actually let's say new chords, it's equal to chords plus move amount, and then let's return new chords, so this should be okay. Great. Let's try to zoom. Great, still works. So let's create actually a pix slider or something. Cool, which gives us value between 0 and 127, so if we divide this by 127, it's going to give us values between 0 and 1. And then we can say pack move amount ff, and we should be able to move through our image using this pix slider. So let's try. Okay, great. We actually want to reverse the y, I believe, because the coordinates going the other way as the pix slider. So cool. Let's actually zoom amount like that. So we're actually able to move through the image. As you can see, at a certain point we will reach the end of the image. So if we zoom a bit in and we want to move through the image, we have to be careful that we don't go outside of the limits. We can actually clip that using our zoom amount in order to kind of rescale these values according to how much we zoomed in. This would be probably a pretty nice way to do that. So let's actually do it. Let's see if we manage. Okay, so I found out this little formula. We can actually clip them in this way. So scale the numbers in this way. We subtract the zoom amount. We subtract 1 from the zoom amount. Then we divide it by 2 because this is basically the difference in the coordinates that, for example, if we put 0.5, so this is basically how much we still got of x coordinates in the negative direction and how much we got of x coordinates in the positive direction. Because we zoomed of 0.5, so we actually double inside the image, we got half of this image on one side and other half on the other side. So that's why we scale it like that. We can actually do the same thing with the epsilon. So let's actually do like this. So let's connect these here and these here. See if this actually works. And of course it doesn't work, because we must take into account also the if we are fitting to the width or fitting to the height. So it's a bit annoying. We need a formula for both of these different cases. So yeah, in this case, for example, it only works with fit to height, but not with fit to width. And if we go with fit to width, we will see the black bands on top and bottom, but not on the sides. But okay, it's pretty okay for the moment. Let's not go too crazy about this. We could actually probably just modify those numbers according to fit to height and fit to weight, maybe inside the code itself. But I will leave this as an exercise for you guys, and I will do this in the next video, because this video is already getting pretty long. And I want to stop it here. So I hope this was clear enough. There were a lot of bugs, but it's also interesting to kind of see how these bugs arise and how they can be corrected. So thank you very much for following, and as always, this patch is going to be available for my patrons right now and for everybody else in 1 week. And let me take again the occasion to thank all my patrons, which are a great community, and I absolutely appreciate so much all the support you gave me, guys. Okay, cool. So thank you very much again, and see you soon in the next video. Ciao, ciao.